Good evening, students. I welcome you back for the second revision lectures of the transition elements. In the first lecture, we have told you what are transition elements. I give you 30 seconds to answer this question, students. What are transition elements? Fast. What are transition elements? Give me answer 30 seconds. 30 seconds, students. Keep your energy high. Keep on answering the questions. Keep on revising the material. What are transition elements, students? What definitions you have for
Yes, so they have partially filled d orbitals in ground state.
ground state or
Excited state.
in any of their oxidation states? So
Yes.
if they are in ground state or if they can form compound, students, in any of their oxidation states in which there are partially filled d orbital, they are transition elements, students. Why are they called transition elements, students? Why are they called transition elements? Because of their position in the
Table, sir.
between S and
S and P block.
S and P block element, students. Important point to note is that in them the d orbital is penultimate. Penultimate means it is the inner subshell, student. It is not the outer subshell.
Yes, sir.
The outer is 4s. Then in the 3D series you see 3D 4s. In the next series you see 4D 5s, 6D 6D 7s, like this. So they
Yes,
are
sir.
called the penultimate energy level. What they called? What we call as student penultimate energy level. What is the general electronic configuration, student? What is the general electronic configuration of the transition elements? What is the general electronic configuration of? So we have defined transit. What is the position of the d block elements? Zinc, cadmium, mercury are not regarded as transition elements. Why zinc, cadmium and mercury are not regarded as transition elements, students?
Yes, sir.
Question has been put up in the paper. What is the reason? Zinc, cadmium, mercury, student, they are not regarded as transition elements. Because we have discussed the electronic configuration of zinc. We discussed the students electronic configuration of zinc, cadmium and mercury. Which group were they? What is the 3D? This is the 3D series, 4D series and 5D series.
Yes, sir.
They belong to which group? What is the group number? What is the group number of zinc, cadmium and mercury, students?
Yes, sir. So it was
Number?
wait, sir. So it's the first series. First.
Group number 12.
Yes, sir. 12, the first series.
All the three belong to group number 12, students.
Hmm.
So when you write the electronic configuration, we have told you how do you write the inert gas is there, student, for zinc, which is 18. Then what did you write, student? How many electrons were there in this? You had 4s2 and 3d. What was the configuration of zinc? 3d10. That will be 5s2 for cadmium. The outermost will be 5s2, 4d10. And for mercury, 6s2 and 5d10, students. So their d subshell is completely filled. When their d subshell is, as you can see, the d orbital, student, the d orbital is, what do you find here? Their d orbital is completely filled.
Hmm.
Completely filled.
Yes, sir.
In the ground state as well as
Um,
in
excited
the
state.
common oxidation state is +2. +2. In the +2, the electrons will go from 4s, 5s and 6s. So in the +2, what will be the configuration? They will have D10 configuration, student, D10, because electrons will leave from the 4s, okay, or 5s or 6s. So
Yes, sir.
this is that is the reason they are not they are not regarded as transition elements. And you will see there are properties which are different. Zinc, cadmium, and mercury, students, they are not typical transition elements. In other words, their properties will be different in many
Hmm.
respects. We will experience that when we will discuss the physical and other properties.
Yes, sir.
This belongs to a zinc group itself, which is a different group. ठीक है?
Yes, sir.
And next question could be there in the paper. What is the general electronic configuration of transition elements? Write the question could be there in the paper. Student, is an important question. Write the general electronic configuration of D elements. So students,
Hmm.
what is the general electronic configuration of the transition elements or D block elements?
Hmm.
What is the general formula? How do you represent?
Sir, 2 minutes, sir. Let me open book. Notes.
How do you write the general electronic configuration, student? Noble gas element. Then what you have, student? What
Yes, sir, the formula is no, basic AR, argon 18,
why I say
3D.
AR? Because there are other elements also. AR is only for
Yes.
3D series. I am saying
Okay, okay.
D block has got
AR, KR, sir, AR, KR, both. Basically, one then 3D, 3D, 1 minus 10, 4s2,
I am
4s.
writing general means you have to write in N form, student.
Sir, N minus 1, D10, NS2.
1 to 10, I am saying 1 to
Uh,
10 electrons can be there in D, or in NS 1 to 2 can be there. You know, we will do one mistake, the question is out. Then if you write like this, you will get 1 mark. If you don't
yes, sir.
write this, 0 mark. There is nothing if you write something else, it's over. Why I am trying to give practice to you, because you should know what type of question, how do you answer the question, students. There will be 4 choices, and out of the 4, we say which is the correct answer of this. Got my point? They can
Okay,
ask
sir.
the question in many ways nowadays. Okay?
Mm-hmm.
Whatever papers have been given in the school, you will send me on WhatsApp the copy of that. Okay? Send me
Okay,
the
sir.
copy of your papers to me. All right, students, you will send the copy.
Yes, yes, sir.
Okay. And all right, these are the questions, student. We ask you question again and again because they are important. They will be there in your exam. So 1 mark question is there. So we have told you 3D series, 4D series, 5D series. Students, all this should be known to you. Very important. Why? Very, very important. Students,
Yes,
repeatedly
sir.
questions are being given to you. They will say that the 3D series begins from and ends from. What is the first element of the 3D series? What is the first element of the 3D series, students?
Mm-hmm.
It starts with what? First series starts where?
Sir, scandium.
Give the atomic number. And it ends with which
21,
element?
21.
Where it ends?
Ends with
If I say 4D
2 minutes.
series,
Sir, I know. Wait.
4D series, which starts
Sir, cadmium.
4D series start from cadmium. Where is cadmium?
No, sir, 4D series starts at Y.
And what is the name of that?
Sir, Y is yttrium.
Ytterbium 39.
Yes, 39.
Array, add 18 in this
Hmm.
magic number. Well, you will get this. And what is the
Yes, sir.
last element? Here, add 18, 48. What will be the that element? Last element of the 4D series, students.
Sir, last element of 40 series is cadmium.
Cadmium. You have to learn all these things again and again. I give practice to you, students. I want your energy should be high when you are taking my class. You will be able to answer question, answer, question, answer. Our lecture is all question, answers.
Mm-hmm.
We have to prepare ourselves, student. What we are preparing for? My job is to prepare you for a match you can win. Not that you can lose, that you have to do practice. Practice means we have to keep our mind power strong and student alive. We cannot be sleeping in the class. We have to keep revising, keep practicing, keep on answering questions. That is the key point, student. Your mind is like a parachute,
Yes, sir.
but if you don't open it, then you will face what? You will just fall on the ground and be dead. If you are jumping from a height of 20,000 feet from an aeroplane by parachute, student, if parachute is not opening, then what will happen? What will happen? You will land
Will
on the ground,
die.
and that's the end of the life. But parachute opens at the right time. You have seen that,
Yes, sir.
and you know how fast they do it. You see, it is the
Mm-hmm.
life is only a question of seconds. Life is a question of seconds. You have seen that parachute games on the sky. Did you see that? The parachute
Mm-hmm.
adventures by teams. You may have seen somewhere videos of that, students. Is it not amazing?
Yes, sir. Very, very.
How many? 10, 15, 20 of them are diving in the air and just floating with the help of the parachute, students.
Yes, sir.
And it is only a game of fraction of second, student. In fraction of
Mm-hmm.
second, if it doesn't open, it's all over. Because the
Yes, sir.
gravitation pull of earth will attract you, you will die. That's the end of the life. So that is the game which they are playing, student. And
Mm.
what we are doing, we can't prepare for an exam, student. Let me tell you. Then we are sleeping. We are not having any risk factor. But there are people who are involved in high risk, and sometimes you see these people have casualties. You don't know about it. There
Yes,
are
sir. So like in Mount Everest, time in Mount Everest.
you have seen Republic Day parade where army people are going student on motorbikes,
Hmm.
which is an adventure. So that is the perfect balance. But sometimes you don't know when they are being trained, there could be injuries. You don't know the
Obviously, sir.
story behind that. So,
Mm-hmm.
student, when you train yourself, you have to practice. And my
Yes,
purpose is
sir.
to give you training. My purpose is to give you practice, practice, practice. Question, 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 answer, student. So, 4D series starts from added 18, 18. And when I say
Huh.
5 series, what is the story of the 5D series? Tell me, in 5D series, student, which element you see first one?
Sir, in 5D. 2 minutes, sir. Um, mm,
5D series, student. Now, something interesting is going to happen. This is my group 3 student. Group number
okay.
is 3. This is my group number 3. Here, student, I am talking of group number 3. What happens in group number 3? In 5D series, student, if you add 18 in this, what is the atomic number? 57. That
Yes,
is
sir.
lanthanum. But immediately the second element, what happens to that, student? Here it was titanium 22,
Hmm.
titanium 22, and below that titanium was, student, zirconium. Zirconium, how much? Add 18, 40. But what happens
Yes,
here?
sir.
Here you see hafnium, student. The atomic number is 72. Atomic number is
Mm-hmm.
72. What happened here? Here you have to add how much? 32.
Mm-hmm.
Not 18. Not 18. So
Yes, sir.
why 18 plus 14? Where are those 14 elements? Where are those 14 elements? Student, what are those 14 elements? Where they are gone, student? 4F series.
Mm-hmm.
You have heard about, you have been told about the lanthanides, students.
Yes,
That
sir.
block begins. This begins a 4F block element, student. Right? And what is
Mm-hmm.
the last element then? Here.
So in lanthanoids.
Now here in 5D series, which is the last element? The last element in 5D series will be what, student? Because now we are adding 32, 32, not 80.
32. Yes, sir.
So if you add in this
So,
32,
sir, it will be lead.
lead,
Wait,
mercury, the
mercury.
atomic number is 80. Now you
Huh.
understood
80. Yes, sir.
why I did all that,
Mm-hmm.
student. We have to be sure what we are doing, student. So then, which is the first element of the lanthanide series, student? Which is the first element of the lanthanide series, which will have atomic number, 58, student? Because 57 is here.
Hmm.
After 57 begins this, which is your cerium student, cerium.
Yes, sir.
58 is cerium. And how many, where it will go? How many you have? 14, 4F12.
Hmm.
It will go from 4F12 student. How much? 4F14.
Okay, sir.
You have to have 14 elements. So what will be the last atomic number? What will be the last atomic number, student? In this case,
Sir, 74.
74. How?
No, no, wait, sir. Sir, 60, 66. Wait,
You
2 minutes, sir.
cannot answer a question without doing it. I
Ah,
repeatedly say to the students,
sure, sir.
students, you must know what we are talking about. No question can be
Um,
answered, student,
yeah,
without.
yes, sir. Sir, 71, 71, 71. Sorry, 71.
Okay, 71. What is the name of the 71 element, student? What is that called?
Sir, 70.
Okay, I give you 1 minute
Uh,
to answer the question.
mm, yes, sir. Sir, it's called
Certain names we,
lutetium.
huh? At least
Sir, it's called lutetium.
lutetium. At least first and the last one we should know,
Lutetium.
student, and one before that also we should know. All this is very important for exam. Ytterbium, 70 is ytterbium, student. So cerium, then cerium and praseodymium, PR. That is the next element, 59.
Hmm.
This 50, what was that? 57 and 58, 59. So you can see
Uh-huh.
that this was a 4F series students. Now when I come to 6D series student, I come to the 6D series student, 6D series.
Yes, sir.
In the 6D series student, tell me the first element is which one, student? 6D series student. So
No
here
idea.
it was 57. If you add
Hmm.
32, how much you will get?
Sir, 89.
89. So 89 is actinium, to remember that. Actinium is 89. So
Okay, sir.
some method of remembering them.
Hmm.
Actini, 9, 89, 89. I mean, I have to
Yes, sir.
try something to, as per my knowledge, to mean some mimics to be used to remember the names and the atomic number 89. But what happens here, if you
Hmm.
will see after 89 student, the next element in 104, you have added 32 here.
Hmm.
104 student,
Yes, sir.
that is ruthenium. So where are these 14 elements that they form? Which series? 5F series. What are they called? What are the 5 series called, students? This was lanthanides. What are those elements? Actinoids.
Okay, sir.
Actinoids.
Noids.
So the first element which you said is that we, how much here you are getting, and so you will start from, you will, what you are going to start, students? 89. After
Hmm.
89, after 89, what you are going to get? 90. What is the name of that element? You know, thorium.
Yes, sir.
And after thorium, you have protactinium, 91. 91 is protactinium. And more important, next is 92. Uranium is very important. You know what is the use of uranium, student? What is the main use of uranium? Question has been asked in the paper. Important.
Sir, it's
Uranium is an
radioactive.
important element for us.
Hmm.
What is it used for?
Sir, bombs. Nuclear energy.
Nuclear fuel. It is a very
Yes,
useful
nuclear
nuclear
energy.
fuel, student. That's why it's in great demand. These are important thing to be learned, is all the actinides are radioactive, students. They are radioactive elements. These are present in trace amounts. That is why they are called rare earth elements. Rare earth
Hmm.
element. Why they are called rare earth, student? Everything can be a question in exam. Be sure. Rare earth elements. Every word I write, you should note it down. It's very important. If you
Hmm.
will listen to my video, you should listen each and every word, because there is a question in every word I am telling you.
Yes, yes,
My
sir.
method of teaching is question answer, question answer. Student, rare earth. What are rare earth elements? They are present only in trace amounts. Student, in earth, because they are radioactive. Which are radioactive? Actinoids. A question has
Mhm.
been asked to students. Actinoids. All these uranium. After the 92 student, they are called transuranium elements. Why they are called
Yes, sir.
transuranium elements? There was a question in some paper. Because they are all synthesized by man, man-made elements. Certain natural elements and man-made elements made by man,
Mhm.
synthesized by man in the nuclear reactions. In the nuclear reaction, they are radioactive elements.
Yes,
They
sir.
are radioactive elements, students. So now you can see that the feeling, you should get a feel of the transition element. What are those? 3D orbital, 4D, 5D, the d subshell is being filled, student. And when you say F block, means the F subshell is being filled, student. The F orbital is being
Mhm.
filled, 4F and
Mhm.
5F. And
Yes, sir.
the differences in these orbitals will make differences in their properties when we will study. When we will study, student. Okay. Thank you very much for helping me and interacting. At least
Yes, sir.
your energy is okay. Now you know, when you come to the class, get prepared, student. Before coming to the class, read the previous lecture very clearly. Watch the video if you are missing anything and come, so that you know what type of questions are coming. Question is, why zinc is not regarded as transition element? Student, 30 seconds for that. We have already answered that question. Question 1. This was given in some paper. You already answered that question in
Yes, sir.
what is that? Zinc is not regarded as transition because 30
Because
seconds.
sir, it has a half filled d orbital,
Where is
incomplete.
the half filled d orbital in
Sir,
zinc?
sorry, sir, sir, it's incomplete.
You have just written the electronic configuration of zinc. Atomic
Hmm.
number is 30.
Yes, sir.
So what is that? We have just written again and again, we are writing. This is a completely filled D subshell. And
Mm-hmm.
D is completely filled. It is not partially filled, it is completely filled in
Mm-hmm.
ground state or in any of its oxidation state.
Okay, sir.
We have repeatedly answered this question because zinc is this and zinc 2 plus ion, zinc is existing in 2 plus oxidation state. Also, student, usually most of the zinc compounds are colorless. They are white in color. Student, they are white in color.
Mm-hmm.
Because
Yes,
there
sir.
will be no DD transition, then we will explain that color of the transition elements also. Zn2 plus will be 4s0 and 3d10. See, this is filled. Electrons filled first in 4s, but electrons, when you lose the electrons, when you remove the electron, they go first from the 4s subshell. Important point. Electrons will, when two electrons will be lost, they will go from the 4s first. So 3d10 for zinc. Therefore, it is not rated. It is not considered as. See why it not a transition. On what ground you can say that scandium is transition but not zinc is? Same question we are repeating. What is the electronic configuration of scandium, student? 21. What is that? What is it? 4s2 3d1. So it has unfilled incomplete d subshell. Therefore, scandium is a transition element. And zinc we have already shown you. It has completely filled d orbital, whereas it has only one electron in the d subshell. Therefore, it is a transition element. Okay? Definition we know. Same question can put in. Silver atom has completely filled 4d10 in its ground state. How you can say that it is a transition element? Silver, you have seen silver, which is where it is present. It is a coinage. Silver is a coinage metal, also called. What is, which group you see the silver, students? Which group you see the silver? Which group you see the silver in the periodic table you have been given? So what you are finding here, student? What you are finding in the case of silver, student? The silver is present in which group? Copper, silver, and gold. You have copper, silver, and gold, students. Which group are these? Tell me, which group is this? What is the group number? What is the group number, students? Tell me which group copper is. Which group is copper? Which group is copper, students? Which group is copper? Which group is copper? Which group is copper? Copper, 11th group. In the we have told you which group is copper. Which is the group number of copper? What is the atomic number of copper, students? You have known copper 29. Copper is 29, student. And what is the atomic number of this? Add 18, 47. And then you add 32. Gold will be what? 79. Okay? They are also called coinage metals. They are used for making coins. You know that. Copper, silver, gold, student. Copper, silver, gold. So what happens in silver when you will write, student, this is what? 4D10 5S1. So what will happen if you will see the oxidation states of silver, student? What will be the result of that? The silver can form compound, student, in which there can be, what can happen in silver? 4D9 configuration, student. It can form compounds in which the silver will be having incompletely filled d subshell. That is why
Okay, sir.
silver there and gold, all these, the gold,
Hmm.
they have other oxidation state, students. Gold 3 plus is also known, student.
Yes, sir.
So students, and you can form the oxidation states of copper 2 plus is also
Hmm.
known, student. So they can form, students, oxidation states in which the d subshell is incompletely filled.
Yes, sir.
And that is the reason, students, they are considered as transition elements, So you can see the variety of the questions which is given in the paper is what we have learned, student, what we have learned. So they have asked the electronic configuration of gold also in the paper. The electronic configuration of gold was asked in the paper, student. What is the electronic configuration of the gold?
Hmm.
In
Yes,
gold,
sir.
you will have which one? 5D and 6S1, 5D10. Student, here you will see there is a change in the configuration. One electron is snatched by the d from the s orbital, completely filled
Yes,
in
sir.
half-filled orbitals are more stable, student, are more stable. This is the outer shell configuration of this. So students, what type of questions are expected in the paper are already known to us. The 3D series contains elements having atomic number from. Next question on the screen is MCQ question. You are objective
Hmm.
type. Tell me the answer of this question number 2, question number 3, question number 4. The 3D transition series contain elements having
Um,
atomic numbers from.
sir, also scandium.
Atomic numbers are given out of the 4, which is the correct answer. You are given 4 choices, A, B,
Oh,
C.
oh, and this was the fourth question.
Question number 4th.
Yes, sir. Given.
What is the answer? A, B, C, D. Which choice is right?
Sir, the answer is 22.
Huh?
22. C part.
Which part?
So C part. C part. C.
It starts with 22. Where it starts from 22? 3D series. Why I'm writing scandium
Okay, yes,
21
sir.
all the time.
Yes, yes, sir. Scandium. Scandium. 21. Scandium. 21. Scandium.
So what is the answer?
Scandium, sir. 21.
21 to what? There are 4 choices.
So 30, sir. 30, 30, 30. Zinc. 30. A part.
A is the correct answer here.
Hmm.
The first transition
So
element is
scandium. Scandium. C
scandium.
part.
While copper, silver, gold are considered as transition element, but zinc, cadmium, mercury are not considered as transition element. Although all mentioned have complete d orbitals. Explain. We have already explained this
हाँ सर यहाँ ये तो अभी हुआ था
because in in the stable oxidation state, student, they can form incomplete D subshell, but this in the stable oxidation state cannot form incomplete D subshell. So
Okay.
same type of questions are repeated, student, repeated. This was a idea of the question answer session, students.
Mm-hmm.
Any doubt? If you have any doubt in this, now you
No, sir. No,
understand
sir.
what type
Clear.
of questions will be there in the paper, student. You know
Yes,
what
sir.
questions are coming. It is not that you are not aware of it. Our our teaching is based on question answer sessions.
Mm-hmm.
So you know what questions will be asked in the paper, objective type or MCQ type or assertive reasoning, anything can be there.
Mm-hmm.
So if we understand it, we can answer it.
Yes, sir.
Now we are coming to the second part of the transition series, students. After the question answer session over, every class will be a question answer session. So you pay attention and keep on records in your notebook, student, because
Mm-hmm.
very important questions, configuration, and all this we are talking about. And the
Yes,
questions
sir.
are not difficult. Let me tell you, very small and minor questions. 1 mark is there for one question, so you have only one answer. Now, the important things to be discussed are the physical properties of the transition element. Physical properties of the transition elements is on the screen, student. Physical properties.
Sir, your voice is breaking right now.
Bias is breaking. I
Yes,
think
sir.
network is okay, but if you can check your network, it
Hmm.
will be okay. Sometimes it drops. It will be okay. Right now, it looks to be okay. Now, what I'm saying, physical properties. Physical property, students. The physical properties
Hmm.
of the transition elements are they are all good conductors of heat, electricity. You know, they are malleable, ductile. What do you mean by sheet? They are, student, malleable
Mm-hmm.
and ductile. Wires you can draw, copper wires you are making, student, for electrical connections. Sheets you are making sheets of them. And gold is the most malleable. Gold is the most malleable substance, metal, student, element. And they have high melting
Mm-hmm.
points. They have metallic luster, students. High melting points. Important point. But there are exceptions. Mercury is a liquid. Mercury is a liquid at room temperature. You have seen mercury? Mercury thermometer?
Yes, sir.
It's a liquid at room temperature. And usually hard and
Mm-hmm.
tough, student, they have high densities. Now the point is to be known, students, that what makes them good conductors of heat and electricity. Heat and electricity, good conductor, is very much dependent on the presence of the electron, students. Whenever certain you have metal ions and free electrons, these free electrons can move, student, they are mobile, so they can conduct heat faster. Electrons will conduct heat faster,
Mm-hmm.
and also these electrons, students, what they can do, they can conduct electricity if there are free electrons present. And you have in the metal ions, in this case you have electrons in the s and n minus 1 d orbital. You know what is the configuration? N
Mm-hmm.
minus 1 d, 1 to 10, and ns 1 to 2. So they have electrons present in d and 1s2, student. Therefore they can be good conductors of heat and electricity. And because of the presence of these mobile electrons, student, they can be beaten into sheets and drawn into wires, you can see. And important point, high melting point I have written. Their melting point is, student, they are hard, you see, they are hard. You have seen alkali metals and alkaline earth metals also.
Yes, sir.
On the left hand side, S block elements. They are soft. They are soft, but these are very hard. Sodium can be cut with a knife,
Mm-hmm.
As compared to S and P block, students, they are more hard than S and P block elements. So question becomes question. If I compare them with S block, ठीक है? S blocks are
Mm-hmm. Yes, sir.
metals, and you are saying D block elements, they are also metals. And then why are they harder and have higher melting points than S block? Now
Mm-hmm.
the question for the paper, what is your answer then? Melting point depends on what factor, students? On what factor their melting point will depend, students? On what factor their melting point will depend for any.
Yes, sir.
It will mainly what type of bonding is present between them, what type of attractive forces are present between them, students. So once you say that they have high thermal, high electrical conductivity, metallic luster, students, and they are having high tensile strength, student. What could be the reason that they are very much hard and harder? They are, we are saying they are very hard. Transition metals are harder if you compare with S and P block. So,
Yes, sir.
what is the reason, student? In S, what is the in S block also you say they are metal. There is a metallic bonding in S block element. In an S block, what is the configuration? NS1 or NS2. Okay? The group one is, this is my group one. This is my group two. That was my alkali metals. These were alkaline earth metals. You are aware of that.
Yes, sir.
Here the electrons which are taking part in the bonding is from S1 and only 2. But here what electrons are taking part in the bonding, student? In the bonding, student, in transition element you have N minus 1, D1 to 10 and NS1 to 2. Therefore, students, in this, in the transition elements, students, you have seen that the not only S orbital but N minus 1 d orbital, student, they participate in, student bond formation. So because of the participation of N minus 1 d electrons, the interatomic metallic bonding will be stronger. Interatomic molecular bonding is a stronger, student. Where? In the transition elements. Clear?
Yes, sir. Yes,
Because they can form, student, ionic as well as covalent type of bonds. NS orbital forms ionic and this forms covalent. So there are two types of bondings and more electrons are taking part in the bonding, student, the D as well as the S. The energy gap between NS and N minus 1 D is very small, students. So therefore, the melting points are more than the as as block element, students, as they are harder than that. They are harder than that. But main transition elements we have told you. But zinc, cadmium, and mercury exhibit few of the properties characteristic of other element. They are treated in separate group. We have already told you zinc, cadmium, and mercury. Reason we have told you. Just now we have given you the reason for that. What happens in zinc, cadmium, mercury, students? The d orbital is completely filled. The d orbital
yes,
is
sir.
completely filled in zinc, cadmium, mercury. You know this is 3d10. This is 4s2. This is 5s2, 4d10. And this is 6s2, 5d10. The d orbitals are completely filled, students. And therefore, they will show lesser property towards the typical transition metals. Clear? That is why they are
Yes, sir. Yes, sir. Yes,
called
sir.
a zinc group element. Zinc group element. This is my zinc group element. Clear to you, students? ठीक है?
Yes, sir. Yes, sir.
Okay. We will proceed further, students. Here we have shown some of the lattice structure of the transition metals. Again, the lattice structure is important, student. In solid state, we will study all this. There is a chapter of solid state in our course in which we will study the various type of crystal lattices which are formed. Here we have shown HCP, hexagonal closed packing,
Mm,
BCC, cubical closed
yes, sir.
packing. So these are the table which have been taken from the NCRT, student, in which they have shown that this scandium is existing as HCP, titanium HCP. These are hexagonal closed packing, body centered, cubical closed packing, chromium, manganese axis as HCP, hexagonal closed packing, and these.
Mm-hmm.
And some of these we have not shown anything. Um, for the crystal lattice structure, they are called the lattice structure, students. Therefore, transition metals, exception zinc, cadmium, mercury, we have already told you. Okay? So, with the exception of
Yes, sir.
zinc, cadmium, mercury, manganese, they have one or more typical metallic structures. at the normal temperatures. So at the normal
Mm-hmm.
temperature, students, they have metallic structures. These are called the metallic structures.
Structure. Yes, sir.
Except, we are always saying except, student. The exceptions we have told you: zinc, cadmium, mercury, zinc, cadmium,
Mercury.
mercury. Student. So they have, these are the metallic structures. More information about this will be there in our solid state chapter. Not much we are interested here. Okay. All right.
Yes, sir.
Proceed further. Now, certain questions which are important will be discussed. Students, the transition metal with exception of zinc, cadmium, mercury are very much hard. You are saying transition metals are hard, students, except zinc, cadmium, mercury, and their melting and boiling points are high. They have high melting points and
Boiling point.
boiling points. What is the reason? We have said that in the transition metals, both d n minus 1 d and both ns12 orbitals, both n minus 1 d, student, and ns orbitals take part in bonding. ठीक है?
Yes, sir.
So when there are more electrons which will take part in bonding, the what will happen? The melting point and boiling points will increase. So here the melting point of, this is my 3D series. This red line is my 3D series, student. What is this? 3D. ठीक है? Scandium, titanium, vanadium, chromium, manganese, which is this? 3D. And this is my 4D,
Mm.
and this is my 5D series. These are the elements of 5D, these are the elements of 4D, these are the elements of 3D. As the atomic number increases, student, what trend you see? What is the trend in the melting point?
Mm-hmm. Yes, sir.
What is the trend in the melting point, student? Tell me. What is the trend in the melting point? You will see that as you are moving, student, in the middle, there is a maxima, then it falls. Then it becomes almost same, then it even decreases. You can see
Yes, sir.
first there is an increase. The melting points, student, what you see? Melting points are increasing first. Okay? And near the middle, they are reaching maximum. Okay? Maximum.
Yes, sir.
And after that, student, what you find? After that, they decrease. How will we explain this, student? Now, what is the answer of this? The maxima is around the middle, chromium. You know, the elements which we said: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc, student. Around the middle,
Mm-hmm.
chromium. See, it maximum is at the chromium. This chromium, this has the maximum melting
Yes,
point,
sir.
highest in 3D. Which has the highest melting point in 3D series? Tell me, chromium.
Chromium. Yes, sir.
And then it falls, and then it almost same falls. So how we explain this trend, student? How can we explain this? The maxima is in the middle. How will we explain this, students? Can you tell me on which factor it depends, student? On which factor it depends? Can I draw any conclusion? Can it be related with the number of unpaired electrons, students?
I think so, sir.
Number of unpaired electrons. You know you have d orbital. ठीक है? Maximum unpaired electrons 1, 2, 3, 4, 5. After that,
Mm-hmm.
what will happen after that? Pairing will start.
Yes,
After
sir.
that, pairing will start. This is my D5.
Mm-hmm.
So if the pairing will start, what will happen? Then unpaired electrons are the electron, student, which are forming bonds. ठीक है? So this indicates the with increase in unpaired electron, students, with increase in unpaired electron student, the bonding becomes stronger. ठीक है, bonding becomes stronger. We can say that the bonding becomes stronger with number of increase in number of unpaired electrons. ठीक है,
Yes, sir.
more the unpaired electrons, more the unpaired electrons, higher is the melting point. Higher is the melting point, students. Higher is the melting point. Is it clear?
Yes, absolutely.
So if you write the electronic configuration of chromium, what is the electronic configuration of chromium is what? Here, 21, 22, 23, 24. So we have written it 18 argon, 4s2 3d4, but it becomes 4s1 3d5. So it has the maximum number of unpaired electrons, chromium. 5 in this, 1 in 4s. ठीक है? So because it has very large number of unpaired electrons, student, therefore the melting point is very high. But what happened in the manganese, student? Why the manganese is less? What is the electronic configuration of manganese, students? 4s2 3d5. This is our manganese. ठीक है?
Yes, sir.
The atomic number of manganese is 25. It also has a unpaired electron, but its value is less. Here is an exception, student. There will be exception, student. So when we have exceptions, can explain, because students 3d5 is half filled. Half filled. What is this? 3d5 is what type of configuration, student? Half
Okay,
filled.
what's the meaning again?
Half filled and completely filled subshells are more stable. Half filled configuration is extra stable.
Yes, sir.
Half filled configuration is extra stable,
Stable.
student. That could be one reason that its melting point is lower. It is not taking part in bonding. Second could be the melting points are also related with the crystal lattice structure, student. What they are related is to the crystal lattice structures.
Okay, sir.
So wherever there are exceptions, there could be other reasons also. Other reasons also. We should know what possibilities are there. And 4D series have higher melting point than 3D, and 5D series have higher melting point than 3D. What could be the answer for these students? What could be the reason? As the elements become heavier, what is happening? Metal bonding is increasing, student.
Okay,
So
sir.
metal bonding is becoming stronger. What I can say, student, the melting point of 5D series is more than 4D, more than 3D. Clear?
Yes, sir.
देखो, this is 4D, it has higher melting point. Melting point is increasing. This is melting point. This is the atomic number. So maxima is around the middle in every case. So melting point, why it is increasing? Why the melting point of 5D is more than 4D? 4D is more than 3D. So when in heavier transition metal, students, what is happening? The metal bonding is increasing. There is the strength of the metal bonding increasing. Okay?
Sir.
So
Yes,
there
sir.
is what we are saying, there is a more frequent metal bonding, students,
Mm-hmm.
in heavier
Elements.
transition metals.
Okay.
In exam, student, we have to note it down. Their questions will be asked on the trend, student. Then you have to be clear. You have to be clear how to answer the question. Is it clear?
Yes, sir. Yes, sir. Clear, sir.
So we have explained to you the and further, students, one more question is coming. You can see that here this copper, gold and silver, what is happening? Their melting points are dropping here. They are less.
Hmm.
What could be the reason, student? The melting points of this is becoming less, students. Their melting point is becoming less, students, as you can see. So greater the number of valence electron, we are saying more is going to be the melting point. More is going to be the melting point, students.
Yes, sir.
So what we see here, what is the reason? As we have already explained, as the number of unpaired electron will decrease, as more and more electrons will become paired, students, their melting point will decrease because the metallic bonding will decrease, and as the metallic bonding will decrease, students, the melting point will decrease. Is it clear? Is it clear,
Sir, yes,
students?
sir, yes, sir, clear, sir, clear, sir.
देखो, I am again and again saying every word is a question, every line
Hmm.
is a question, student. We must be able to understand it, must be able to understand. Metals of the second and third series have greater enthalpy. Now we are talking of enthalpies of atomization. Next,
Yes, sir.
I'm talking of
Sir,
enthalpies.
your voice is breaking again.
Huh?
Sir, your voice is breaking again.
Voice is breaking.
Hmm.
Okay, you have understood up to here.
Yes, sir, yes, sir.
Okay, then we will continue this next part of it in the next class. Here we have
Hmm.
discussed the melting points and important trends and question
Okay.
answers of transition metals. Then we will meet you in the next class with more question answers on the transition metal, students, and discuss
Okay.
further more properties and important ionization energies and chemical properties of the transition metal. Okay, then
Thank you,
bye
sir.
bye.
Thank you, sir.
I'll meet you in the next class. Keep yourself prepared with question answers. Okay, then. Good.